Alright, so in this section we're going to introduce functions. This is going to be the main difference between this class Math 120 and the previous class 114. This is going to be something that we will see throughout the course of the semester, and today we're just going to go ahead and introduce it. We're going to talk about what functions are, and then we're going to introduce the concepts of domain and range. So first off, we have some vocabulary. We have function. This is a relation in which each member of the input corresponds with only one output. Functions map or are related to real-world problems. Quite often, real-world scenarios, we use functions to represent them. So for instance, we can sit here and an example of a function is, can you be in two places at one time? And the answer is no. You can either be here or there, but you cannot be in two places at one time. So if we treat you as an input and where you are as the output, that is an example of a function. So let's go ahead and continue. We have domain. Domain is the set of all inputs. For most of what we're going to look at, these are going to be the x values or the x coordinates. We also have range. Range is the set of the outputs. For most of our cases, this is going to be our y values or our y coordinates. One thing to note is with functions, y values can appear multiple times. We only care about the x values. The x values can only appear once. Now we're going to be looking at tables, graphs, and equations. When we get to graphs, we have something called the vertical line test. And what this says is if there is at least one vertical line that passes through the graph more than once, it is not a function. So let's go ahead and start with some examples. So the first thing we're going to look at is we're going to look at tables. We're going to start by identifying the domain and range, and then we want to know, is it a function? So for table 1, remember that the domain is our x coordinates. And so what are our x coordinates in this table? Our x coordinates are -2, -1, 0, 1, and 2. I'm going to use squiggly braces around these. Squiggly braces, what we mean by squiggly braces is x equals each one of these values. We also have range. So for our range, remember that we want our y coordinates. And our y coordinates here are 0, 1, 2, 3, and 4. The last question that we want to know is, does this represent a function? This one does represent a function. Each x value appears once. There is no repetition in our x column, so it is a function. Okay, let's go ahead and look at table 2. Table 2, if we start with our domain, we want to list out the x coordinates. So we have -3, -2, -1, 0, and 1. For our range, we want our y coordinates. We have -3, 0, 1. We have another 0, which I do not need to include again. We also have another -3. Again, we do not need to include it again. So our range consists of 3 values, -3, 0, and 1. And the question is this a function? And the answer is still yes. Remember, function, we only care about x values. Y values can appear multiple times. X values can appear only once. So it is a function. All right, let's come down to table 3. Let's start with our domain. Our domain, we have x is -3, 0, 1. We already have 0 and -3 on there, so we are done. What is our range? Our range is -1, -2, -3, -4, and -5. So I want to know, is this a function? The answer is no, this is not a function, because -3 is being mapped to 2 different y values. This is not allowed in functions. Similarly, 0 maps to 2 different y values. This is not allowed in a function. And so, no, it is not a function. -3 and 0 appear more than once. Okay, so those are our tables to get us started with. Right. The next thing we want to look at is we want to look at some graphs. And we're not going to come up with domain and range on these. We just want to look at these pictures and determine if it is a function. So the first one, I want to know, is it a function? For each one of these, we're going to use the vertical line test. Vertical lines go up and down. And so I want to know, can I draw a vertical line through this first graph that crosses more than once? That only crosses once, 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 once. Note that there is no vertical line that I can draw through this graph that will cross more than once. So this is a function. If we come to our second example, I want to know if this is a function. And so here's the thing. That's a horrible vertical line. Here is a vertical line. Note that it crosses the graph at more than one point. It crosses twice. And I just need to find one single line that does this in order to disprove function. So this is not a function. The last example, if we go ahead and look at this, can you find a vertical line that will cross through the graph more than once? And the answer is no. This is a function. All right, so those are some examples of pictures of functions and not functions. So now let's go ahead and play around with domain and range. Next thing that we're going to look at is equations. So I'm going to go ahead and tell you which one of these are functions and which are not. And we're going to kind of talk about, okay, so what are we looking for? The first one we have is this is a function. This is a linear equation. And it actually is a linear function. One thing to note is all lines except for vertical lines are going to be functions. So the only linear equation that is not going to translate into function is x equals some number. All right, if we look at the next one, x squared minus 5y equals 4. This is a function. We will be studying these later this semester. We actually call this a quadratic function. All right, y equals 3x minus 4 over 2x minus 5. This is a function. We actually call it a rational function. Okay, on the bottom, we have x squared plus y squared equals 4. Now this is not a function. If you graph this actually is the graph of a circle. And so what makes this not a function? What's one of the things we want to look out for? Right here, y squared. This makes this not a function. If I plug in y equals 1 and y equals -1, I get the same thing. And so we run into problems right here. Okay, so if ever you see a y squared, you can automatically state not a function. Okay, y equals the square root of 3x minus 5. This is a function. And we actually call it a radical function. And the last one, y equals 2 to the x. This is a function. This is one that you probably have not seen before. We will be looking at these later on this semester. This is known as an exponential function. Now, this class is based mostly, we're going to be talking about functions. So you will probably see things that are not functions later on in your studies. But basically, everything that we're going to look at this semester does fall under the category of function. All right, let's go ahead and continue. So, the first thing we're going to do is we're going to start with some graphs. We want to determine domain and range. So the first question I'm going to ask you is it a function? And if we look at graph 1, yes, this does pass the vertical line test. Each x value corresponds to only one y value. So we can go ahead and find the domain and range. Now when we looked at tables, we listed out all of the x values. But when we look at graphs, we have to be careful because we're no longer looking at points, we're actually looking at a curve. And in between any 2 points, there's an infinite number of more points. So we're going to go ahead and do this using set notation, and interval notation. So when we talk about domain, domain, remember, is the x coordinates, and we want to go left to right. So for instance, when I look at graph 1, I want to know what is my leftmost x coordinate. Well, my leftmost x coordinate occurs right here. This is a -5. I'm going to use a less than or equal to. And then we want our rightmost x coordinate. If we continue this graph to the right, it stops right here. And what is our x coordinate of that point? It is a 4. So my x is somewhere, or my x values, is going to be between -5 and +4. -5 and +4 are both included. This is what you would write in set notation. Now remember that set notation, we do need our squiggly brackets, we need our x, and we need our line. Now if I did this using interval notation, my leftmost value is -5, my rightmost value is 4, and I use square brackets on both of these because it is included. Alright, so that is domain. So now let's talk about range. Range, remember, is the y values, or the y coordinates. And when we talk about range, what we want to look at is we want to look bottom to top. So we're going to find our bottommost point and our topmost point, and we want to keep the y coordinates. So again, if we look at graph 1, my bottommost point is right here. I want my y coordinate of this point, which is -3. Now the main thing to keep in mind is if you're going to use set notation, make sure that you use the right variables. Remember, range is the y coordinates, so inside my set notation I need to make sure that I say -3 is less than or equal to y. And then how far do we go? So what is my highest point? My highest point is up here. We want the y coordinate of this point. The y coordinate of this point is 5. To finish off my set notation, I'm going to include my squiggly brackets, my y, and my little bar. Okay, interval notation. If we wrote this in interval notation, this is just going to be -3, 5, and they are both going to have brackets. This is one of the benefits of using interval notation, is that you don't have to worry about which variable to put inside your statements. If you use the wrong variable for domain, if I used y, then it is considered incorrect. Same thing if I used x when I'm talking about my range. So that is one of the nice things about using interval notation, is you don't have to keep track of the variable. Alright, that takes care of graph 1. So let's go ahead and look at graph 2. Now, when we look at graph 2, we're going to start with domain, and I want to know how far to the left does this go? What is my leftmost point? Well, if you look here, note you have an arrow. This arrow goes 2 directions. It goes left or right, and it goes up and down, up or down. So when we're looking at domain, we want to know how far to the left does this go? Well, this arrow goes forever to the left, meaning negative infinity. What about the other arrow? How far to the right does it go? This arrow not only goes forever up, it also goes forever to the right. And so in terms of domain, when you see these arrows that go both directions, this is all real numbers. If we wrote it in interval notation, this is negative infinity to positive infinity. All right, that is our domain. So be very careful when you see these arrows. Note that they don't stop, they do keep going. All right, if we look at our range, what do we have? We have our lowest point. We do have a lowest point on this. I want my y-coordinate of this point. It is -3. And what we have here is this goes forever up, which means that y is always going to be greater than or equal to -3. Let me go ahead and move that down just a little bit. If I wrote this in interval notation, my bottommost number is -3. It has a bracket. This goes forever up, and so it goes to positive infinity. Okay, so those are some examples there. The other thing that is nice about interval notation over set notation is note that your set notation, depending on what your graph looks like, it changes what your inequality statement looks like. Are we going to the left? Are we going to the right? Are we going up? Are we going down? And then which inequality do you need? Whereas with interval notation, you just need to know bottom and top. You don't have to worry about which direction your arrow points and that sort of thing. Let's go ahead, try a couple more examples and see what we can do. Okay, if we look at example graph 3, we want to start with our domain. Our domain, note that we have everything to the left of 3. How far to the left does this go? This goes forever to the left. What is my rightmost value? It is 3. So if we wrote out our domain, we get x is less than or equal to 3. This is my set notation. If I do my interval notation, this is negative infinity, comma 3, with a bracket. Okay, for my range. My range, what is our bottommost y-coordinate? It is 0. And how far up do we go? Again, that arrow not only continues to the left forever, it goes forever up. So we have y is greater than or equal to 0. Again, if we did this in interval notation, what is my bottommost y coordinate? It is 0 with a bracket. It goes up forever, so we get 0 to infinity. Okay, last one. Okay, this is a linear function. And so if we look at this, what do we have in terms of left to right? Well, if we look at these arrows, this arrow goes forever to the left. This arrow goes forever to the right. So our domain is all real numbers. In interval notation, that is negative infinity to positive infinity. All right, if we talk about the range, how far down does this go? Again, we have an arrow that tells me this goes forever down. This arrow tells me we're going forever up. And so my range for this is also all real numbers. Or, in interval notation, negative infinity to positive infinity. All right, that takes care of domain and range. Please take your time on this homework. If you need other sources, I encourage you to read the textbook or look for functions online. And as always, I encourage you to contact me if you have any questions so that we can go ahead and address them. This is something that we will continue to study throughout the course of the semester. After this, we're going to be breaking it down into linear functions, polynomial functions, rational functions, etc., etc. But this is not something that's going away. This is the key thing for this course. So again, if you have questions, please contact me.